prove by induction that the sum of 1 over r times r plus 1 is equal to n over n plus 1 if r start from 1 all the way to n. Well, to do that, we need to do the proof by induction of step 1. We need to show that the statement is true for n equals to 1. And to do that, we have to look at the left-hand side and the right-hand side. Here is the left-hand side. We make r equals to 1 because it just goes to 1 for n. We have 1 over 1 times 1 plus 1. That would become 1 over 1 times 2, and that equals a half. For the right-hand side, we do the same thing, but in this case, n equals 1, because we're saying n equals 1. We have 1 over 1 plus 1, because this is 1, 1, and therefore that equals a half. This is true. Likewise, that is true. This statement is true for n equals 1. Step 2. We need to assume that the statement is true for n equals k. In that case, we have the equation here, and we want to replace n with k. So we're transforming n to k. Therefore, we have to write k instead of n. Still, r start from 1, and the equation here, and that will now be equal to, instead of n, we have k over k plus 1. And now we're going to use this for step 3. And that's why we did that. Step 3. Prove the statement is true for n equals k plus 1. To do that, we basically bring in the equation again. Then we want to change the n to be equal to k plus 1. We have k plus 1 for n, and the r begins from a 1 with the formula that equals to, now n is k plus 1 over k plus 1 plus 1. That will be k plus 2. This is where we're going to arrive at. This is what we need to show. The way to show this is to rewrite the equation for and use step 2. We go from r equals to 1 to k, and then the last term will be the k plus 1. And so you want to replace the r here with k plus 1 and that r here with k plus 1. So that will be k plus 1, k plus 1 plus 1. And that will be k plus 1 for the r here as the last term, and k plus 1, that's k plus 2 for the last term. Now you want to bring in the formula, the end value for that one, which is replaced with k. So you want to have, because you're going to k, so n is k here, so you have to have k and k plus 1. So we're going to bring that in here. So that'll be k over k plus 1. For that, you replace the n with k, which is what we did in step 2. We're bringing in step 2 now to here. And now we want to then simplify this. To simplify this, we want to make it the common denominator. We want to multiply this denominator with k plus 2 and the numerator with k plus 2 to have the same denominator. That would become k times k plus 2 divided by k plus 1 times k plus 2 plus this one here. Because they have common denominators, we just want to add the top. K times k is k squared, k times 2 is 2k, then plus 1 over the common denominator. And we need to factorize the top. Let's bring it here. If you factorize that, you get k plus 1 times k plus 1. That's k plus 1 squared divided by the common denominator. And can you see that the k plus 1 comes to k plus 1, and therefore that equals to k plus 1 over k plus 2. That is what we wanted. So we wanted that, which is what we've got here, and we've proven that that is true as well. That is what we wanted to show using step 2, and we've shown that, and also we've shown that here as well. That's the step, that's what we're trying to prove, and we've got that here, which means that we've proved the statement is true for n equals k plus 1. Finally, for step 4, we must write the 4-point statements to get full mark. And to do that, we write, since the statement is true for n equals 1, we must write that down. And if this statement is true for n equals k, we must write that down. Then it is true for n equals k plus 1. We have to write that down. Finally, we need to write the statement must be true for all n greater or equal to 1. All these statements must be written down to get the full mark.